Hello everyone. Today we are doing the topic of trigonometry. Trigonometry is not the topic from which question comes in NEET, but many a question which come in NEET utilizes trigonometry to solve them. For example, the chapter of SHM, AC, waves, they can be understood better if you have proper knowledge of trigonometry. So without wasting time, let's start doing the topic of trigonometry. First thing that we need to focus upon is the definition of an angle. If we have a circle of radius r in which an arc of length x subtend an angle theta at the center. So we say that this angle theta in radian is given by the definition theta equals to x by r. Here you need to take care of two things. First, the angle theta is in radian. And second, in the world of physics, whenever we talk about any angle, it is in theta. So if you find some formula in which there is a theta, that theta should be taken in radian. Now let's think of a special case. What if the arc we have has the same length as the semicircle? If the arc is so big that its length is same as that of semicircle, then what will be the angle subtended by this arc at the center? We already know that this angle will be nothing but 180 degree. But what do we call this angle in radian? So we will say the length of this arc will be half the perimeter. The perimeter of whole circle is 2 pi r. So the length of this arc will be half of that. So the length of this arc will be pi r. So the angle subtended by this arc at the center in radian will be given by the length of the arc, which is pi r, upon the radius. So that becomes nothing but pi radian. Here we got one important correlation. We know that this angle is 180 degree. Yes. And this angle is also equal to pi radian. Yes. Hence we can say that 180 degree equals to pi radian, or pi radian equals to 180 degree. If we double the angle on both the sides, then we can say 2 pi radian equals to 360 degree. So the angle subtended by complete circle at center is 360 degree, and that is equals to 2 pi radian. Once we know the relationship between angle in radian and degree, we can make a formula out of it. What is the relationship between angle in degree and radian? We already know that pi radian equals to 180 degree. Yes, sir. Beta, if pi radian equals to 180 degree, then what is 1 degree equal to? If I tell you that 10 banana cost you 30 rupees, then what is the cost of 1 banana? You will say, sir, the cost of 1 banana will be equals to 30 by 10, that will be 3 rupees. If I ask you what is the cost of x banana, you will say then the cost of x banana has to be equals to 3x rupees, right? So this simple utilization of unitary method will help us to find the formula for degree to radian conversion. We know that pi radian equals to 180 degree. Yes, sir. Hence we can say that 1 degree equals to pi by 180 radian, dividing both the side with 180. If beta 1 degree equals to pi by 180 radian, then what is x degree equals to? So multiplying x both the side, you will say x degree will be equals to pi into x by 180 radian. So just keep this simple formula in mind. X degree equals to pi into x by 180 radian. Again, I am repeating, in the world of physics, whenever we talk about any angle, it is always in radian. So you must know degree to radian conversion. So let's take some simple example. What is 30 degree equals to? So 30 degree will be equals to pi into 30 by 180 radian. That will be equals to pi by 6 radian. You can cancel out 30 and 180. You get 6 in denominator. What is 60 degree equals to? 60 degree will be equals to pi into 60 by 180 radian. That will be nothing but pi by 3 radian. So this is a simple formula. Just keep it in mind. X degree equals to pi into x by 180 radian. Moving on. Sometimes we need to utilize very small angle, like the angle subtended by a star on your eye. So sometimes we need to work with angles which are even smaller than 1 degree. So we have defined a system. We say that 1 degree can be divided into 60 minutes. The symbol for minute we use is this single dash. And each minute is divided into 60 seconds. For seconds we use double dash. Just the way in our clock we say 1 hour equals to 60 minutes. And every minute equals to 60 seconds. So this is just another way of writing smaller angle. So think that you have got this small angle of 1 degree. If you divide this angle into 60 equal parts, then each angle will be equals to 1 minute. And then if you further divide that each minute into 60 equal parts, then each smaller angle will be equals to 1 second. So if I tell you that 1 degree equals to 60 minutes, and 1 minute equals to 60 seconds, and I ask you 1 degree equals to how many seconds, you will say, sir, just like 1 hour has got 60 minutes and every minute has got 60 seconds, in the same way 1 degree will have 3600 seconds. So just keep in mind these small operations, they might be useful in some questions. Moving on, let's practice a question here. The diameter of a planet subtend an angle of 0.01 degree at a point on the Earth. Determine the diameter of planet given that its distance from Earth is 3 into 10 to the power of 12 meter. What they have given me in the question is the angle subtended by planet at a point on Earth and the distance of that planet from Earth. And what are they asking me? They are asking me the diameter of the planet. So let's see. Let's say this is the case. This is the planet and this planet has diameter d. And let's say the distance of this planet from the Earth is d and the angle subtended by this planet at a point on Earth is theta. We will treat the distance of the planet from Earth, d, kind of radius, and we will treat the diameter of the planet as the arc length. From the definition of angle in radian, we know that the angle theta subtended in radian equals to arc length upon radius. Here, in place of x, we can write diameter of planet upon the distance of planet from Earth, which is capital D. So once we have established this relationship, the question is over. They have given me theta, they have given me capital D, I need to find out small d. So simply here, we can say that theta equals to diameter of planet upon distance of planet from Earth. Here, remember that you must take theta in radian. In the question, they have given me theta in degree. So how to convert angle from degree into radian? We have already learned. We have learned that x degree equals to pi into x by 180 radian. Simply use that here. So you will say the diameter of planet equals to distance of planet from Earth times theta. Do take care, you have to take theta in radian. So just substitute the value and multiply. So in place of d, you will write 3 into 10 to the power of 10, and in place of theta, you will write 0.01 into pi by 180. So you can write d, you can write theta in radian, and then you do the calculation, you get 5.2 into 10 to the power of 8 meter. Not a difficult question. The only purpose of teaching this question is to tell you how can you determine the diameter of a planet if you know the distance of planet from Earth and what is the angle subtended by planet at a point on Earth. Let's move on. Let's say we have this standard right angle triangle. For the angle theta, perpendicular is x. For the angle theta, base is y, and for the angle theta, hypotenuse is z. Similarly, for the angle 90 minus theta, perpendicular is y, base is x, and hypotenuse is z. First of all, let's learn the definition of sine theta. Sine theta is x by z, which is perpendicular upon hypotenuse. Cos theta is y by z, which is base upon hypotenuse. And tan theta equals to perpendicular upon base, that will be x by. If you divide sine theta and cos theta on both the sides, so on the left hand side you will get sine theta by cos theta. On the right hand side the z will cancel and you will get x by y. And you already know that x by y equals to tan theta. Hence we get one more relationship, that tan theta is nothing but sine theta by cos theta, and you should keep it in mind. Now, using three lengths x, y and z, we can create 6 type of ratio. We can do x by y, which is tan. We can do y by x, which is cot. We can do x by z, which is sine. We can do z by x, which is reciprocal of sine, which is cosine. We can do y by z, which is cos, and we can do z by y, which is sec, which is nothing but reciprocal of cos. So remember that sine theta and cosec theta are reciprocal of each other. Moreover, sine theta can be written as cos of 90 minus theta. Similarly, cos theta has reciprocal, which is sec theta, and cos theta can be written as sine of 90 minus theta. And the reciprocal of tan theta is cot theta, and tan theta can also be written as cot of 90 minus theta. So if I say that sine theta equals to cos of 90 minus theta, we should understand that I am saying sine 30 degree is as good as cos of 90 minus 30, which is cos of 60 degree. Sine 15 degree is same as cos 75 degree. Sine 20 degree is same as cos 70 degree. Now, just like sine and cos are complementary function, Tan and cot are complementary function. In the same way, sec and cosec are also complementary functions. So sec of theta is same as cosec of 90 minus. Let's move to the next slide. Let's now talk about trigonometric table. You must remember trigonometric table for the standard angle like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. We will even learn how to remember the trigonometric table for the higher angles. Now better remember that sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. The value of sine 0 is same as the value of cos 90. The value of sine 30 is same as the value of cos 60 because they are complementary function. So if you remember the value of sine theta and cos theta, you can definitely get the value of tan theta. We know that tan is nothing but sine by cos. So tan theta will be 0 by 1, 0, half by root 3 by 2, that is 1 by root 3, 1 by root 2 by 1 by root 2, that is 1, root 3 by 2 upon half, that is root 3, and 1 by 0, that can be said as not defined, or somebody might call it infinity. So if you know sine and cos, you can find out tan as the ratio, you can find out cosec as the reciprocal of sine, you can find out sec as the reciprocal of cos, and you can find out cot as the reciprocal of tan. So without wasting time, let's move on. Let's understand now higher angle conversion. Sometimes we need to find in question the value of sine 120 degree or cos 120 degree, which are higher angles, which are angle greater than 90 and less than 180. So now what to do in such cases? Better remember these two trigonometric identities. This will help you. First, sine of 90 plus theta, sine of 90 plus theta can be written as cos theta. Sine of 90 plus theta can be written as cos theta. So you can say sine 120 degree is as good as sine of 90 plus 30. Yes, sir. Sine of 90 plus 30 is as good as cos 30. Yes, sir. And cos 30 equals to root 3 by 2. So you already know what is the value of sine 120. Similarly, if rather than finding out sine of higher angle, you need to find cos of higher angle. Let's say, for example, you need to find cos 150 degree. So this trigonometric identity will help you. Remember that cos of 90 plus theta equals to minus sine theta. Cos of 90 plus theta equals to minus sine theta. So you can say cos of 150 degree is same as cos of 90 plus 60. Yes, sir. Cos of 90 plus 60 is minus sine 60. And sine 60 is root 3 by 2, but there is a minus in front. So you get cos 150 as minus root 3 by 2. So similarly, using the same process, you can find out sine 150, cos 135 and the other angles. So you can make up a bigger table which have got angles like 0, 30, 45, 60, 90, which we have already done, plus more angles like 120, 135, 150 and 180. You will be able to remember these values easily once I tell you about unit circle and the graph of sine theta and cos theta. But I still want for a child to score more in competitive examination, they must remember the value of cos 120, cos 150 by heart, because that becomes useful many a time in vector addition and subtraction. Okay, so without wasting time, let's move on. Now let's say again we have the same right angle triangle. For angle theta, perpendicular is x, base is y, and the hypotenuse is z. Now we know that sine theta equals to perpendicular upon hypotenuse, that is x by z. So if sine theta equals to x by z, if sine theta equals to perpendicular upon hypotenuse, how can we write perpendicular in terms of hypotenuse and sine theta? So simple. If sine theta equals to x by z, then you can say x equals to z sine theta. So x is nothing but z sine theta. So this length can be written as z sine theta. Similarly, we know that cos theta equals to y by z. Yes, sir. So you can say this length y to be nothing but z cos theta. This is a really useful operation, as many a time we need to find components. Let's say we have a vector of magnitude r and we need to break down this vector into two components which are mutually perpendicular to each other. Why are mutually perpendicular vectors important? We will talk about that in the chapter of vectors. So now this length perpendicular will be equals to r sine theta, and the length along the base will have length equals to r cos theta. It's easy to remember. In the formula of sine, we get perpendicular. Yes. So perpendicular is r sine theta. In the formula of cos, we get base. So base length is nothing but r cos theta. So the component of the vector having magnitude r in the direction making an angle theta with it is nothing but r cos theta. And the perpendicular component is nothing but r sine theta. You must keep this in mind. This will be very handy while taking components in the later chapters. Now let's talk about unit circle. The name itself says unit circle. Unit circle, a circle of radius 1. So let's visualize a circle of radius 1 centered at the origin. So if we have this circle of radius 1 centered at the origin and there is this point on the circle, for different choice of theta, this point will be different. So as the point goes once around the circle, the theta changes. For theta equals to 0, the point will be here. For theta equals to 90, the point will be here. For theta equals to 180, point will be here. Theta equals to 270, point will be here. Theta equals to 360, again here. Theta equals to 360 plus 90, 450, point will be here. So now what I'm trying to say is, think of a unit circle that is a circle of radius 1 having its center at the origin. Now you will say the coordinate of this point is, let's say, x comma y. So x coordinate will be this length and y coordinate will be this length. What we have just learned about the component, from there we can say that the length x will be equals to 1 cos theta. It's the base length. X has to be equals to 1 cos theta. And the length y will be equals to 1 sine theta. The length of the perpendicular equals to length of the hypotenuse times sine theta. So as x coordinate is 1 cos theta, that can be written as cos theta. And as the y coordinate is 1 sine theta, that can be written simply as sine theta. So from here we can say that the coordinate of this point, rather than calling them x comma y, we can call the coordinates of this point to be cos theta comma sine theta. So what you need to take care here is, x coordinate represents cos theta, y coordinate represents sine theta. All trigonometric function repeats themselves after an angle of 360 degree. What is the meaning of this statement? All trigonometric function repeat themselves after an angle of 360 degree, which is nothing but 2 pi. If the particle starts from here and goes around the circle once by an angle of 360 degree, it will be at the same point. Yes. If the particle will be at same point, its x and y coordinate will be same. Yes, sir. If x and y coordinate will be same, then cos theta and sine theta will be same. If cos theta and sine theta will be same, it means that all the 6 trigonometric function will have the same value. That's why all trigonometric function repeat themselves after an angle of 360 degree. So from here, we can say that sine 15 degree will have the same value as sine 375 degree, and it will have the same value as sine 735 degree. Because one can say that sine of 375 degree is nothing but sine of 360 degree plus 15 degree, and as the angle changes by 360 degree, you get back to the same point, and hence all the 6 trigonometric functions have the same value. Moving on. Now let's say there is this point on the circle. Remember that x coordinate represents cos theta and y coordinate represents sine theta. For the choice of theta such that theta lies between 0 and 90, the particle on circle will be anywhere here. So the particle will lie in the first quadrant. If the point lies in the first quadrant, you can say that both x and y coordinate will be positive. So for the choice of theta such that the point lies in the first quadrant, both x and y coordinate are positive. If both x and y coordinate are positive, then cos theta is positive as well as sine theta is positive. Why? Because x coordinate represents cos theta and y coordinate represents sine theta. So both of them are positive. Sir, what? If sine theta is positive, what will be the sign of cosec theta? Beta, cosec is reciprocal of sine. So if sine is positive, cosec is positive. So what will be the sign of sec theta? Beta, sec is the reciprocal of cos. If cos is positive, then sec also have to be positive. So what will be the sign of tan? Beta, tan theta equals to sine theta by cos theta. If sine theta is positive as well as cos theta is positive, both of them are positive, then their division will also be positive. Hence tan theta must be positive. Sir, So for the choice of angle of first quadrant, all the trigonometric functions are positive. Yes. So for the choice of angle of first quadrant, all the 6 trigonometric functions are positive. For the choice of angle in the second quadrant, let's say the point is somewhere here. The choice of theta is between 90 degree and 180 degree. So the point is in the second quadrant. For such a point, we know that the x coordinate will be negative while the y coordinate will be positive. Remember that x coordinate represents cos theta and y coordinate represents sine theta. As for such a point, the x coordinate is negative and y coordinate is positive, you will say that cos theta is negative while sine theta is positive. Sir, if cos theta is negative and sine theta is positive, what is the sign of sec theta? Beta, sec is the reciprocal of cos. So if cos is negative, sec is negative. So what is the sign of cosec? Beta, if sine is negative, if sine is positive, then its reciprocal cosec will also be positive. So what will be the sign of tan theta? You can again say tan theta equals to sine theta by cos theta. Here sine theta is positive while cos theta is negative. So the overall tan theta comes out to be negative. So in second quadrant, cos is negative, sine is positive, tan is negative, and sec is negative, cosec is positive, cot is negative. Moving on. For the angle in third quadrant, let's say the point has moved such that the choice of angle is between 180 degree and 270 degree and the angle lies in the third quadrant. For such an angle, you can say that the x coordinate will be negative as well as y coordinate will be negative. Both of them are negative. As x coordinate is negative, you will say cos theta is negative. As the y coordinate is negative, you will say sine theta is negative. Beta, if both x coordinate and y coordinate are negative, which is sine theta and cos theta are negative, what will be the sign of tan theta? So tan is sine by cos, so tan theta will be negative upon negative, negative upon negative becomes positive, hence tan theta will be positive. So for the choice of angle in the third quadrant, tan theta is positive, sine theta is negative, cos theta is negative. Let's move on to the fourth quadrant. If the choice of angle is such that the angle theta lies between 270 degree and 360 degree. If the angle lies between 270 degree and 360 degree, then you will say, sir, the x coordinate is positive and the y coordinate is negative. If x coordinate is positive and y coordinate is negative, x coordinate represent cos theta. So cos theta will be positive. Y coordinate represents sine theta. So sine theta will be negative. Hence, you will say x, that is cos theta, will be positive and y, that is sine theta, will be negative. Beta, if cos theta is positive and sine theta is negative, what will be the sign of tan theta? Tan theta is sine by cos, so negative by positive, that becomes negative. So the easy way to remember this is add sugar to coffee. In first quadrant, all the 6 trigonometric functions are positive. For the choice of angle in second quadrant, sine and its reciprocal cosec are positive, all the other 4 are negative. For the choice of angle in third quadrant, tan and its reciprocal, which is cot, is positive and all the other 4 are negative. For the choice of angle in fourth quadrant, cos and its reciprocal sec is positive and all the other 4 are negative. Now, what does the graph of sine theta look like? Just remember that sine theta, let's say this is the point on unit circle, and this point goes once around the circle and comes back to the same place. Remember that sine theta is represented by y coordinate. So beta, when theta is 0, remember this is a unit circle. When theta is 0, what will be the coordinate of this point? So when theta is 0, the coordinate of this point will be 1, 0. When theta is 90 degree, what will be the coordinate of this point? The coordinate of this point when theta becomes 90 degree will be equals to 0, 1. When similarly theta is 180 degree, the coordinate of this point will be minus 1, 0. And when theta is 270 degree, the coordinate of this point will be 0, minus 1. Sine theta is represented by y coordinate. So for theta equals to 0, y coordinate is 0. For theta equals to 90, y coordinate is 1. For theta equals to 180, y coordinate is again 0. For theta equals to 270, y coordinate is minus 1. So remember that sine theta represents the y coordinate. So sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is again 0. So 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1. So remember, This is how sine theta changes as the theta keeps on changing. So as the theta increases from 0 to 90, the value of sine theta increases from 0 to 1. As the theta further increases from 90 to 180, the value of sine theta decreases from 1 and drops down to 0. As the theta further increases from 180 to 270, the value of sine theta changes from 0 to -1. And as the angle changes from 270 to 360, the value of sine theta changes from -1 to 0. So if we draw the graph of sine theta versus theta, the graph goes like this. Sine 0 is 0, yes sir. Sine 90 is 1. Sine 180 is again 0. Sine 270 is -1. Sine 360 is 0. So 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1. We know that all trigonometric functions repeat themselves after 360 degrees. So if we keep on increasing the angle after 360 degrees, what does the graph look like? So if we keep on drawing for higher angle, we get the same curve repeating over and over again after every 360 degree, which is after every 2 pi angle. The maximum value of sine theta is 1 and the minimum value of sine theta is -1. So now we will talk about the graph of cos theta. Again, the same unit circle. Remember that cos theta is represented by x coordinate. For theta equals to 0 degree, the coordinate is 1, 0. For theta equals to 90 degree, coordinate is 0, 1. For theta equals to 180 degree, coordinate is -1, 0. For theta equals to 270 degree, coordinate is 0, -1. Cos theta is represented by x coordinate. So cos 0 is 1, cos 90 is 0, cos 180 is -1, cos 270 is 0, cos 360 is again 1, and as the angle keeps on increasing, for every 360 degree angle change, you get the same value. So a new dance move for cos. 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0. So if we draw the graph of cos theta versus theta, the graph looks like this. Remember that cos 0 is 1, cos 90 is 0, cos 180 is -1, cos 270 is 0, cos 360 is again 1. And then after 360 degree, the same graph keeps on continuing. Now let's talk about some trigonometric identities. If we have this right angle triangle, from Pythagoras theorem, we can say that x square plus y square will be equals to z square. We can create three identities by dividing each term with z square, or each term with y square, or each term with x square. Let's understand first. Divide each term with z square. If I divide each term with z square, the hypotenuse length whole square, we get x square by z square plus y square by z square equals to 1. What is x by z? So sine. What is y by z? So cos. So x by z is sine, y by z is cos. So when I write x square by z square plus y square by z square equals to 1, I am nothing but writing sine square theta plus cos square theta equals to 1. Similarly, rather than dividing each term with z square, we can divide each term with x square. On dividing each term with x square, we get x square by x square plus y square by x square equals to z square by x square. X by x square by x square becomes 1. Y by x square, y by x square, this is cot square theta. Z by x square, hypotenuse upon x, this is reciprocal of sine, so that is cos x square theta. So we get another trigonometric identity, 1 plus cot square theta equals to cos x square theta. Similarly, if we divide each term by y square, we get x square by y square plus y square by y square equals to z square by y square. Y square by y square becomes 1. X by y whole square, x by y whole square perpendicular upon base whole square is nothing but tan square theta. So you get tan square theta plus 1 equals to z by y whole square. What is z by y? Y by z is cos. So z by y has to be inverse of cos, that will be sec. What you get here is tan square theta plus 1 equals to sec square theta. So these are the three trigonometric identities we should keep in mind. Now, there are some identities. Sine of a plus b can be written as sine a cos b plus cos a sine b. Cos of a plus b can be written as cos a cos b minus sine a sine b. Tan of a plus b can be written as tan of A plus tan of B upon 1 minus tan A tan B. You need to remember these three formulas. So memorize it with me right now. Sine of A plus B is sine A cos B plus cos A sin B. Cos of A plus B is cos A cos B minus sin A sin B. Cos of A plus B is cos A cos B minus sin A sin B. Tan of A plus B is tan A plus tan B upon 1 minus tan A tan. So you need to remember these three formulas. Now using these three, you can find out what is the sine of double angle. If you need to find what is sine of 2 theta, you can think of sine of 2 theta as sine of theta plus theta. And sine of theta plus theta can be written as sine theta cos theta plus cos theta sin theta. Now sine theta plus cos theta, sine theta cos theta plus cos theta sin theta is nothing but 2 sine theta cos theta. So hence we can say sine 2 theta is nothing but 2 sine theta cos theta. Similarly, we can find out what is cos of 2 theta. We can say that cos of 2 theta is nothing but cos of theta plus theta. Cos of A plus B is cos A cos B minus sin A sin B. So cos of theta plus theta will be cos theta into cos theta minus sin theta into sin theta. Now cos theta into cos theta will be cos square theta. Yes sir. Sin theta into sin theta will be sin square theta. So you get cos 2 theta is nothing but cos square theta minus sin square theta. I will say this second one is very important in physics. Why? Let's see. One can say in place of cos square theta, using the trigonometric identity that sin square theta plus cos square theta equals to 1, I can write that cos square theta equals to 1 minus sin square theta. Yes sir. So if I substitute in place of cos square theta 1 minus sin square theta, what I get is cos 2 theta is 1 minus sin square theta minus sin square theta. So cos 2 theta is nothing but 1 minus 2 sin square theta. Similarly, rather than substituting cos square theta, I can substitute sin square theta. From sin square theta plus cos square theta equals to 1, I can even say that sin square theta equals to 1 minus cos square theta, and we can substitute that value here. So what we get is cos 2 theta is cos square theta minus 1 minus cos square theta. So this becomes equals to 2 cos square theta minus 1. So all these three variations are important. Cos 2 theta can be written as cos square theta minus sin square theta. Yes. It can be written as 1 minus 2 sin square theta. Yes. And it can also be written as 2 cos square theta minus 1. Let's dwell in little more. First, a question. What is the value of sine 75 degree? You know that 75 degree is not a standard angle. It is not 30, 45, 60, 90. So how to find sine 75 degree? We have just learned the formula sine of A plus B is sine A cos B plus cos A sin B, and we are going to use that here. One can say that sine 75 degree can be written as sine of 45 plus 30. Yes sir. Sine of 45 plus 30, using the formula sine of A plus B is sine A cos B plus cos A sin B, I can say sine of 45 plus 30 is sine 45 cos 30 plus cos 45 sin 30, sine 45 cos 30 plus cos 45 sin 30. And I know the value of all four of them. Sine 45 1 by root 2, cos 30 root 3 by 2, cos 45 1 by root 2, sin 30 half. So when you substitute the value, you can see that the denominator is common to root 2. So you simply get answer root 3 plus 1 by 2 root 2. This is the value of sine 75 degree. Easy thing to remember, given that you remember that sine of A plus B is sine A cos B plus cos A sin B. Now let's talk about super important formula. Why I'm calling it super important formula? Because this is one of the trigonometric formula which will be used very widely, starting from the first chapters of kind of vectors till wave optics. So this is really important. You have to focus right now. So now here we know that cos 2 theta can be written as cos square theta minus sin square theta. Yes sir, you just told this is important. And then we learned that cos 2 theta can also be written as 1 minus 2 sin square theta by eliminating cos square theta and writing it as 1 minus sin square theta. Moreover, we learned that we can even write cos 2 theta as 2 cos square theta minus 1. Right? Now, first let's focus on this one, that cos 2 theta is 1 minus 2 sin square theta. So here you can say that 2 sin square theta equals to 1 minus cos 2 theta. So bring this 2 sin square theta to left hand side and this cos 2 theta to the right hand side. So if 2 sin square theta equals to 1 minus cos 2 theta, converting this into half angle, in place of theta substituting theta by 2. So here you will get 2 sin square theta by 2 equals to 1 minus cos of 2 into theta by 2, and 2 into theta by 2 becomes theta. So you can say 2 sin square theta by 2 equals to 1 minus cos theta, and this is something important that is used many a time in problems in physics. So 1 minus cos theta is 2 sine square theta by 2. You need to remember that 1 minus cos theta is 2 sine square theta by 2. We can get another formula in terms of cos using this identity. Here we can say 2 cos square theta equals to cos 2 theta plus 1. Just take this one to the left hand side. So 2 cos square theta is cos 2 theta plus 1. Again convert it into half angle. So in place of theta, substitute theta by 2 here and here. So when you substitute theta by 2 in place of theta, what you get is 2 cos square theta by 2 equals to cos of 2 into theta by 2. That becomes cos theta plus 1. So hence from here you can write 1 plus cos theta equals to 2 cos square theta by 2. So these are two super important formula. They are used many a time and you need to remember that. 1 minus cos theta, 2 sine square theta by 2. 1 plus cos theta, 2 cos square theta by 2. 1 minus cos theta, 2 sine square theta by 2. 1 plus cos theta equals to 2 cos square theta by 2. If you remember the basic body of formula and you are confused that if let's say it's written 1 plus cos theta equals to what, and you are sure that it's either 2 sine square theta by 2 or 2 cos square theta by 2, but which one I do not remember, then the test is that just substitute theta equals to 0 and you will get the answer. If you take theta equals to 0, you know that 1 plus cos 0 becomes 2. So if I take here on the right hand side 2 sine square theta by 2, will I get 2? No, I will get 0 because 2 into sine square 0 will be 0. So 1 plus cos theta has to be 2 cos square theta by 2. This is how I personally remember them. So moving on. Small angle approximation. Now this is again a very important heading. Visualize a triangle with a really small angle. So this angle theta is really small. If the angle theta is really small, then this perpendicular length has to be small. Larger side corresponds to larger angle and smaller side corresponds to smaller angle. So this length y will be small. Now think of this right angle triangle with a very small angle theta. As the length of perpendicular is negligible, can I say that the length of base and hypotenuse will be nearly same? So we can say that the base will be nearly same length as the hypotenuse. I am not saying they are equal, I am saying they will be nearly equal, and hence we say small angle approximation, not the small angle exactness. So we know that sine theta equals to perpendicular upon hypotenuse, that will be y by z. Tan theta equals to perpendicular upon base, that will be y by x. And theta angle can be said to be y by x. How can you say theta equals to y by x? Better, since both these lengths z and x are nearly equal, let's call them equal to r. Now we can treat this length y as a arc and we can say that theta equals to the arc length upon radius, and the radius is nearly equals to x is nearly equals to z. So in place of radius I can write x here. So we know that sine theta can be said to be y by r. So how are you calling sine theta y by r? Beta, I just said z is equal to r. Okay, rather than saying x and z, we are calling them same term r. And tan theta can also be said to be y by r. In place of x, I have written r. And theta can be said to be x by r. Sorry, this won't be x by r. Sorry kids, here it should be y by r. In place of x, we have written. So we can say for small value of theta, sine theta which is y by r equals to tan theta which is y by r equals to theta which is y by r. So for small value of theta, sine theta is nearly equal to tan theta is nearly equal to theta. For small value of theta, sine theta is nearly equal to tan theta, and that is nearly equal to theta. For small value of theta, what will be the value of cos theta? Sir, cos theta is base upon hypotenuse. Since base and hypotenuse will be nearly equal, you will write cos theta as r by r, so that becomes nearly equals to 1. So just remember, for small value of theta, sine theta is nearly equal to tan theta is nearly equal to theta, and cos theta is nearly equals to 1. But there is a catch here. You must take angle in radian. In the world of physics, whenever we write anything and we do not mention angle has to be taken in what, it goes without saying angle should be taken in radian. So here beta, take the angle in radian. So here is a practice question for you. This is why. Here is a practice question for you. Find the value of sine 0.1 degree. So you will say, sir, 0.1 degree is a small angle. I will say yes. And sir, for small value of theta, sine theta can be approximated to theta. So I can say sine of 0.1 degree is nearly equals to 0.1. This will be totally wrong. Why, sir? Why? Because beta, for small value of theta, sine theta is nearly equal to tan theta is nearly equal to theta, but you must take the angle theta in radian. So here, as the angle is given in degree, you must first convert it from degree into radian, and you will write for a small value of theta, sine theta is nearly equals to theta, but theta should be taken in radian. So you can write sine of 0.1 degree is same as sine of 0.1 into pi by 180. Didn't we learn that x degree equals to pi into x by 180 radian? So sine of 0.1 degree is same as sine of 0.1 into pi by 180 radian. Now, once you have got this angle in radian, now you can say sine of theta is nearly equals to theta. So this will be nearly equals to 0.1 into pi by 180, and you can further write it as pi by 1800. Now you can substitute pi as 3.14 and solve it further if you wish to. Moving on. Negative angle conversion. Think of this unit circle again and think of 2 points. One for which the angle theta is positive and one for which angle theta is negative. If you take the angle theta as negative, you end up in fourth quadrant. In fourth quadrant, which trigonometric function is positive? Then in fourth quadrant, cos and sec are positive and the other four are negative. So beta, it's simple to remember. Sine of minus theta is same as minus sine theta. Why? Because in fourth quadrant, sine is negative. Cos of minus theta is same as cos theta. Why? Sir, in fourth quadrant, cos is positive. Tan of minus theta is same as minus tan theta. So we need to remember sine of minus theta is minus sine theta, cos of minus theta is cos theta, and tan of minus theta is minus tan theta. Now once we know this, we can find the difference formula. We have learned that sine of a plus b is sine a cos b plus cos a sine b. Now using this thing, you can tell what is sine of a minus b. Sir, how? Very easy. See better. You will say sine of a minus b is nothing but sine of a plus minus b. So in place of b, substitute minus b, that becomes a minus b. Now, since you know that sine of a plus b is sine a cos b plus cos a sine b, we can say that sine of a plus minus b is sine of a into cos of minus b plus cos of a into sine of minus b. Yes, sir. What is cos of minus b? Sir, cos of minus b is cos b. Cos of minus theta is cos theta. So you get here sine a cos b plus cos a sine b. What is sine of minus theta? So minus sine theta. So what is sine of minus b? Sir, sine of minus b is minus sine b. So here you get a minus outside and this becomes minus cos a sine b. So if you know the formula of sine of a plus b, and if you know that sine of minus theta is minus sine theta, cos of minus theta is cos theta, tan of minus theta is minus tan theta, you can write down the formula of sine of a minus b, cos of a minus b, and tan of a minus b. I leave out the derivation of other two to you. We know that sine of a minus b is sine a cos b minus cos a sine b. Cos of a minus b is cos a cos b plus sine a sine b. And tan of a minus b is tan a minus tan b upon 1 plus tan a tan b. So we have now got subtraction formula as well. Now, phase comparison becomes an important article in the chapter of SHM, in the chapter of waves, in the chapter of AC. So you should know how to compare phase. The first rule of phase comparison is that the trigonometric function should be same. Phase comparison is nothing but the difference in the input angle. We will talk about this more when we learn SHM, waves and AC, but I want my kids to know the formula right from here. The basic condition for phase comparison is that the trigonometric function should be same. So you should know how to convert cos into sine, how to convert minus sine into sine, and how to convert minus cos into sine. So you need to remember this small thing, and this will be useful at a later stage for sure. Better remember that cos of theta can be written as sine of theta plus 90. Sir, cos of theta can be written as sine of 90 minus theta. Yes, you are right. Cos of theta can be written as sine of 90 minus theta, and this is how you can convert cos into sine for phase comparison. But it's useful to use cos theta equals to sine of theta plus 90 degree rather than using 90 minus theta. I will explain this more when I teach you AC or SHM or wave for sure. But right now, you need to be a little bit of Maggasur and remember this. So cos theta equals to sine of theta plus 90 degree. Next, how to convert from minus sine to sine. So we say that sine theta minus sine theta is same as sine of theta plus 180 degree. Minus sine theta is same as sine of theta plus 180 degree. Next, how do we convert minus cos theta? We say that minus cos theta can be written as sine of theta plus 270 degree. So what do I need to remember? So first, cos theta can be written as sine of theta plus 90 degree. Minus sine theta can be written as sine of theta plus 180 degree, and minus cos theta can be written as sine of theta plus 270 degree. This will be really useful at a later stage when we talk about phase comparison. Now, we will talk about the most commonly used Pythagorean triplet. Which is the most commonly used Pythagorean triplet you have seen? Sir, the most commonly used Pythagorean triplet I have seen is 6, 8 and 10. 6 square plus 8 square is 10 square. You are right. Or I have seen 3, 4, 5. Yes, you are again right. But aren't 3, 4, 5 and 6, 8, 10 brothers? 6, 8, 10 is just double of 3, 4, 5. So the most commonly used Pythagorean triplet is that of 3, 4, 5 or its multiple. Kind of like if you make every term 3 times, you will get 9, 12 and 15. Now what you need to remember is this diagram, is this triangle. In the triangle of 3, 4, 5, the angle opposite to 4 is 53 degree. The angle opposite to 3 is 37 degree. Remember that larger side corresponds to larger angle and smaller side corresponds to smaller angle. So the angle opposite to 4 is large and the angle opposite to 3 is comparatively small. So the angle opposite to 4 is 53 while the angle opposite to 3 is 37 degree. If you remember this particular triangle, you will always be able to find the value of sine 37, cos 37, sine 53, cos 53. So first, either we can have 3, 4, 5, yes, or its elder brothers. If I double each side, we get a triangle of sides 6, 8 and 10. And if we triple each side, we get a triangle of sides 9, 12 and 15. All three are similar triangles because their respective sides are in a given defined ratio. So now question is, what is the value of sine 37? So first of all, let's see sine 37. Forget the other two, focus on the first triangle. Sine 37. For the angle 37, the perpendicular is 3 and hypotenuse is 5. So sine 37 has to be 3 by 5. What is the value of sine 53? For 53 degree, perpendicular is 4 and hypotenuse is 5. So sine 53 degree has to be 4 by 5. What is the value of cos 37? Cos 37, for angle 37, the base is 4 and hypotenuse is 5. So cos 37 has to be 4 by 5. And what is the value of cos 53? For the angle of 53, the base is 3 and the hypotenuse is 5. So cos 53 has to be 3 by 5. So you will be able to find these four angles just if you remember this particular triangle, and it's easy to remember. Larger side corresponds to larger angle and smaller side corresponds to smaller angle. So now we will talk about the maximum and minimum value of certain function. What is the maximum and minimum value of sine theta? So you will say, sir, for sine theta, now we remember the dance 0, 1, 0, minus 1, 0, 1, 0, minus 1. So the maximum possible value of sine theta is 1 when theta is 90 degree, and the minimum possible value of sine theta is minus 1 when theta is 270 degree. So you will say the minimum value of sine theta will be minus 1 and the maximum possible value of sine theta will be 1. Easy. Next question, what is the minimum and maximum possible value of cos theta? So for cos theta, the dance is 1, 0, minus 1, 0, 1, 0, minus 1, 0. So cos 0 is 1, that is the maximum possible value, and cos 180 is minus 1, that is the minimum possible value. Hence, the maximum and minimum possible value of cos theta is also minus 1 to plus 1. Next, what is the maximum and minimum possible value of a sine theta? So what is a? A constant. And what is variable here? Theta. So sir, the maximum possible value of sine theta is 1. So the maximum possible value of a sine theta is plus a. Okay. What will be the minimum possible value of a sine theta? Sir, the value of a sine theta will be minimum when sine theta will be minimum. The minimum possible value of sine theta is minus 1, so the minimum possible value of a sine theta will be minus a. Hence, the value of a sine theta must range from minus a to plus a. What is the maximum and minimum possible value of b cos theta? Sir, the same thing. Here, the value of b cos theta will change because the value of cos theta changes. For b cos theta to be minimum, cos theta should be minimum and the minimum value is minus 1. So the minimum value of b cos theta is minus b. What is the maximum possible value of b cos theta? Sir, the maximum possible value of b cos theta is when cos theta is maximum and plus 1. So then the maximum possible value comes out to be plus b. Hence the maximum and minimum possible value of b cos theta is plus b and minus b. Minimum minus b, maximum plus b. Next, what is the minimum and maximum possible value of a sine theta? So for minimum possible value of a sine theta, take the minimum possible value of sine theta, which is minus 1. Hence the minimum possible value comes out to be minus a plus b. That can be written as b minus a. For the maximum possible value of a sine theta plus b, take the sine theta as maximum. The maximum possible value of sine theta will be 1. Hence the maximum possible value of a sine theta plus b will be a plus b. So the range of value of a sine theta plus b will be from b minus a to b plus a. Next, what will be the range of value of a cos theta plus c? So you will again say, sir, see, for minimum value, take the minimum value of cos theta, which is minus 1. When you take the minimum value of cos theta minus 1, you get minus a plus c. For maximum possible value of a cos theta plus c, take the maximum possible value of cos theta, and the maximum possible value of cos theta is 1. So the maximum possible value of a cos theta plus c will be a plus c. Hence, the value of a cos theta plus c will range from c minus a to c plus a. Now comes the big king. What is the maximum and minimum possible value of a sine theta plus b cos theta? The students think that the value of a sine theta plus b cos theta will be minimum when both sine theta and cos theta will be minimum. The minimum possible value of sine theta is minus 1. The minimum possible value of cos theta is minus 1. Hence, the minimum possible value of a sine theta plus b cos theta is minus a minus b. And similarly, the maximum possible value is when sine theta and cos theta both are maximum equals to 1. So the maximum possible value is a plus b. But this is wrong. Why, sir? See better. Can sine theta and cos theta be together 1? Sine 0 is 0. Sine 90 is 1. Cos 0 is 1. Cos 90 is 0. So if you choose, can you choose an angle theta for which both sine theta and cos theta are simultaneously 1? Not possible. Then what is the maximum possible value of a sine theta plus b cos theta? Right now I want to just mug up this result. I promise you, either in differentiation or while teaching SHM or waves, I will explain this. Why is the maximum possible value of a sine theta plus b cos theta is under root of a square plus b square. Right now just remember, it will be useful later. So the maximum possible value of a sine theta plus b cos theta is a square plus b square plus, and the minimum possible value of a sine theta plus b cos theta is minus under root of a square plus b square. Hence, we get the range of value from minus under root of a square plus b square to plus under root of a square plus b square. You need to remember this last one. Out of all of them, the one which is not that obvious is the last one. You need to either differentiate the function or use some phasor diagrams to explain this thing. Right now, I want you guys to remember it. So let's do an example to understand it. This is an example kind of from SHM. The maximum possible value of x for x equals to 3 sine omega t plus 3 root 3 cos omega t. What is the maximum possible value of x? So you will say, if x equals to 3 sine omega t plus 3 root 3 cos omega t, what is the maximum possible value of x? The maximum possible value of a sine theta plus b cos theta is nothing but under root of a square plus b square. If the maximum possible value of a sine theta plus b cos theta is under root of a square plus b square, then what will be the maximum possible value of 3 sine omega t plus 3 root 3 cos omega t? So the maximum possible value of 3 sine omega t plus 3 root 3 cos omega t is nothing but under root of 3 square plus 3 root 3 square. 3 square plus 3 root 3 square becomes under root of 9 plus 27, that becomes under root of 36, which is nothing but 6. Hence, the maximum possible value of 3 sine omega t plus 3 root 3 cos omega t is 6. This is all in trigonometry. So now we will be doing the topic of average value. This is a simple small article. There is only one single definition involved. If you get it, it will be helpful in solving many questions. So without wasting time, let's start. So first of all, we will now talk about average value. Let's say there is a quantity y which changes with the change in x. So there is a quantity y which changes with the change in x. And let's say the y-x graph looks something like here. You can see as the quantity x changes, you can see that the quantity y also changes. So with the change in x, the quantity y is changing. It is not at all constant. Then how do you find the average value of y over a range of x? You can see here as the x changes from x1 to x2, the value of y is not constant. It first increases, then decreases and keeps on changing. So which single value of y can be taken as the average value for the whole range of x from x1 to x2? So there is just one definition here. The average value of y, the symbol of average goes like this. When I write this, it means average value of t. When I write this, it means average value of v. When I write this, it means average value of x. So what's written here is called the average value of y. So you will say the average value of y for x between x1 and x2 is given by how much? The average value of y over a range of x is given by the area under the y-x graph, which is nothing but the shaded area. The average value of y over a range of x is given by the area under the y-x graph upon the change in x. What is the change in x here? The change in x is nothing but the final value minus the initial value, that is x2 minus x1. So you need to keep this definition in mind. The average value of y over a range of x is given by the area under the y-x graph between x equals to x1 and x equals to x2 upon the change in x, which is x2 minus x1. So let's see a question based on this particular. Looking at the graph, determine the average value of y when x changes from x equals to 0 to x equals to 4. So here they have given me a graph. In this graph, I can see as x changes from 0 to 1, y changes from 0 to 20. As x further changes from 1 to 3, y remains constant at 20. As x increases from 3 to 4, y decreases from 20 and becomes 0. So question is, what is the average value of y over this range of x? So the average value of y over a range of x is given by the area under the y-x graph upon the change in x. The area under the y-x graph from x equals to 0 till x equals to 4 will be nothing but the area of this trapezium. How do we write the area of a trapezium, let's say, which has height h and the side length a and b? We write the area of a given trapezium as half into sum of parallel sides into the height. This is how we write the area of a trapezium. So now here we will say the average value of y as x changes, y changes. The average value of y over a range of x is given by the area under the y-x graph upon the change in x. So here you write the area under the graph from x equals to 0 to x equals to 4 upon the change in x, that is final value of x minus the initial value of x, that is 4 minus 0. So the area under this y-x graph will be given as half into sum of parallel side. This length is 4, this length is 2, so half into 4 plus 2 into the height. The height is nothing but 20. So this whole numerator is nothing but the area of trapezium, which is half into sum of parallel side into the height, divided by the change in x, which is the final value of x minus initial value of x. So that is 4 minus 0, which is 4. So on calculating this, this becomes 6, or simply you cancel out, you get here at 10. So you get 6 into 10, 60 by 4, which is nothing but 15. So the average value of y over the range of x is 15. Let's see more. Now, next question. The graph shows the velocity time graph of a particle. Find the average velocity between time equals to 1 second and time equals to 5 seconds. You need to find the average velocity from time equals to 1 second till time equals to 5 seconds. So again, you will say the average value of y over a range of x is given by the area under the y-x graph upon the change in x. So the average value of v over a range of t will be given by the area under the vt graph upon the change in t. So the area under the vt graph from time equals to 1 till time equals to 5 will be given by this. Better notice that the area above the x-axis will be treated as positive area. So this area will be taken as positive. And the area below the x-axis will be treated as negative area. So this area will be treated as negative area. So how to find the average value of velocity over time equals to 1 to time equals to 5? So sir, it's simple. Just find this positive area. How? Sir, it's a trapezium. Half into sum of parallel side into height. And then find the area of this triangle. How? Sir, it's a triangle. Half into base into height. Then find out the overall area and divide it with the change in time. That will give you the average velocity. So let's see. The average velocity will be given by area under VT graph from time equals to 1 till time equals to 5, which is this area, upon the change in time. Initial time is 1, final is 5, so the change in time is 5 minus 1, that is 4. The area from time equals to 1 to time equals to 3, the area from time equals to 1 till time equals to 3 will be treated as positive. And from time equals to 3 till time equals to 5, time equals to 3 till time equals to 5 will be treated as negative. So you will say the overall area under the VT graph will be area of positive part. Area of positive part will be half into sum of parallel side. This length is 2. This length is 2 minus 1, that is 1. So half into 2 into 1. Sorry, half into 2 plus 1 into the height. The height here is 10 plus the negative area of this triangle. Half into this height is minus 10 into 2. So see, the area of triangle comes out to be negative. So the overall area between time equals to 1 and time equals to 5 divided by the time gap. On solving, you will get the average speed comes out to be 5 by 4 meter per second. So now let's talk about another important super useful concept. If y is a linear function of x, if y is a linear function of x, when I say that y is a linear function of x, I do not mean y is proportional to x. This is proportional. When I say that y is a linear function of x, it means that y equals to mx plus c. Linear function means the graph of which goes like a straight line. So simply the equation of straight line. So if y is a linear function of x, then the graph of y and x is a straight line. So visualize y to be a linear function of x, you will get a straight line graph. Now let's say x changes from x1 to x2, and when x changes from x1 to x2, y changes from y1 to y2. Here you can see the height is increasing. Question is, what is the average value of y when the x changes from x1 to x2? So you will again say, sir, the average value of y over a range of x is given by the area under the y-x graph upon the change in x. So here we can say that the average value of y will be the area of this trapezium upon the change in x, which is x2 minus x1. The area of this trapezium will be how much? So the area of trapezium will be half into sum of parallel side y1 plus y2 into the height, which is nothing but x2 minus x1. So this is the area of trapezium divided by the change in x, which is x2 minus x1. So what you get here is x2 minus x1 get cancelled. So if y is a linear function of x, then as y changes from y1 to y2, then the average value of y is given by y1 plus y2 by 2. This is really important, and I'm going to use it everywhere while teaching you physics. So again, listen to the argument. If y is a linear function of x, then as the value of y changes from y1 to y2, the average value of y can be taken as y1 plus y2 by 2. Let's practice a question, a simple question based on this. If the velocity linearly increases from 10 meter per second to 30 meter per second, determine the average velocity. So a particle has initial velocity of 10 meter per second, final velocity of 30 meter per second, and it is said that the velocity increases linearly. If the velocity increases linearly from 10 and become 30, then what is the average velocity? You can simply say, sir, the average velocity has to be initial plus final by 2. Initial is 10, final is 30, so the average value has to be 10 plus 30 by 2, which is nothing but 20 meter per second. Easy thing. I will use it many times while solving questions. So now, teaching you the most important thing. It will be used many a time in SHM everywhere. So without wasting time, let's see. What is the average value of sin x over one complete cycle? We know the graph of sin x versus x. Yes, sir. It goes something like this. It keeps on repeating itself after the angle of 2 pi. What is the average value of sin x as x changes from 0 to 2 pi? We have learned that the average value of y over a range of x is given by the area under the y-x graph upon the change in x. Here, what will you take the area under the sin x versus x graph as x changes from 0 to 2 pi? So you will say, sir, for first half cycle, the area is positive. For the next half cycle, the area is negative. So what is the area under the sin x graph as the x changes from 0 to 2 pi? You know that this area is 0. And since the area is 0, that's why the average value of sin x as x changes from 0 to 2 pi comes out to be. So the average value of sin x over one complete cycle as the x changes from 0 to 2 pi is 0. Third, why is this necessary to say that the average value of sin x over one complete cycle is 0? What if we change the x from 0 to pi? If somebody asks you what is the average value of sin x as x changes from 0 to pi, you can't call it to be 0. Why? Because within this duration as x changes from 0 to pi, the area you must consider is only the positive area. And since you are considering only the positive area, the average value of sin x should be taken as positive. Similarly, when x changes from pi to 2 pi, the average value of sin x has to be negative. Mention in the comment what is the average value of sin x as x changes from pi by 2 to 3 pi by 2. What is the average value of sin x when x changes from pi by 2 to 3 pi by 2. Okay. So the average value of sin x over one complete cycle comes out to be 0. The average value of both sin x and cos x over one complete cycle is 0. You need to remember this. Why? If we draw the graph of cos x, cos 0 is 1, then cos 90 is 0, cos 180 is minus 1, cos 270 again 0, and cos 360 comes out to be 1. If you look at one complete cycle from 0 to 360 degree, here you have got positive area, here you have got positive area, and here you have got negative area. But the total area under the cos x versus x graph from 0 to 360 comes out to be 0. Since the area under the cos x versus x graph from 0 to 360 is 0, the average value of cos x over one complete cycle is 0. So just remember, the average value of sin x and cos x over one complete cycle comes out to be 0. I will use it in some later chapters. So now, the last thing to learn in the average value heading. What is the average value of sine square x? Sine square x. We know that the range of value of sin x is from minus 1 to plus 1. The minimum is minus 1, the maximum is plus 1. But sine square x, it's a square. It can never ever be negative. So what is the range of value of sine square x? The sine square x, the square of anything can't be negative. So the minimum value of sine square x is 0. And the maximum possible value of sine square x is when the magnitude of sine x is maximum. And the maximum possible magnitude of sine x is 1. So the maximum possible magnitude of sine square x is also 1 square, that is. So as the value of sine x changes between minus 1 and plus 1, the value of sine square x changes between 0 and 1. So if we look at the graph of sine square x versus x, so this is the graph of sine square x versus x. When x is 0, sine square x is 0. Then it increases, become 1, then drops, become 0, then increases, become 1, then drops, become 0, then increases, become 1, then drops, become 0. How to exactly find this, I will teach you guys under the heading of integration. But for now, think over it. If a quantity changes from 0 to 1, 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 and you don't know mathematics, what will you guess the average value to be? So God has blessed us that the average value of sine square x over one complete cycle comes out to be half. The average value of sine square x over one complete cycle comes out to be half because it changes from 0 to 1, 0 to 1, 0 to 1, exact midpoint, half. So just remember the average value of sine square x and cos square x over one complete cycle is. This will be used somewhere later. So sine square x is always positive and same is true for cos square x. So just remember the average value of sine x, the average value of cos x over one complete cycle is 0, and the average value of sine square x and the average value of cos square x over one complete cycle is the average value of sine x equals to average value of cos x equals to 0. Average value of sine square x is same as the average value of cos square x, which is equals to half, and this statement is true when you are talking about one complete cycle. So what if they are not talking about one complete cycle? Those type of questions don't come in NEET, but we will learn under the heading of integration what to do if they are not talking about one complete cycle. So that's all for today. Hope you like this session. Stay tuned to Scomore.